Hey guys, hope you're doing well. Here we have a grade 9 November 2019 mathematics paper. It's going to have paper 1 and paper 2 content combined, and it's 100 marks and it should take around 2 hours long. Which of the following numbers is rational? Okay, so when you look at the word rational, I want you to think of a nice number. Rational is a nice number. So for example, if you go take your calculator, right, and you go type in square root 3, quickly do that. Let's see what we get. If you type in square root 3, look at that. It's really ugly, right? You get whoopsie, what happened there? You get 1.732050808. Can you see these numbers are not repeating? Now go type in this on your calculator. You'll see that you get an error. Okay, so that's an error, and then go type this on your calculator and you get an ugly number with lots of decimals. If you go type this on your calculator, you get a beautiful number of 4. So the answer for this one is definitely B. There are 120 learners in grade 8 at a certain high school. If the ratio of boys to girls is that, how many boys are there? Okay, so we've learned about this before, right? How to take a big number and divide it up into a ratio. So the big number is 120. The ratios are 3 to 5. So all that you do, okay, is you add these two numbers together. So that'll give you 8. So that means there's 8 boxes. You can think of it like this. There's 8 boxes. 3, 4, 5, 6, 7, 8. 3 of them are girls because they said girls first. Girls is 3, okay? So girl, 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 and then the rest is boys. Okay, now if you have 120 learners, how many, and you have 8 different boxes, then how many learners would go in a box? Well, you would say 120 divide by 8, and that'll give you 15. So that means there's 15 people per box. Now, if they then say how many boys are there, well, the boys is 5 of those boxes. So you could say 15 multiplied by 5, and that'll give you 75. So the answer is A. Convert the following number to scientific notation. Okay, so what you do is you look at these numbers and you find the first non-zero. So there's a non-zero, and you're going to say 8, then you're going to say comma, and then you're going to put all the numbers after that one. So 9, 1, 2, 3, and then you're going to say times 10. Now, you see the decimal was over there. Now we've put it all the way over here. Okay, so that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we're going to put here negative 10. Okay, because this is or let me rather say the following rules. When you move decimal to the right, then we're going to use times 10 to a negative number. You're going to put a negative over there. And then when you move decimal to the left, then you're going to use times 10 with a positive number. Okay, so what I mean is, you see how we took this decimal and we moved it 10 places to the right. So when you move the decimal to the right, use a negative over here. So we're going to have 8.9123 times 10 to the negative 10. If this expression is equal to 0, then what is the value of x? Okay, now some learners, they're going to go make this really complicated, and they're immediately going to start multiplying these brackets together. But that is not, I mean, it's not wrong to do it that way, but then you're going to end up coming back to this step in the next step, and so you're just wasting a bit of time. Let me show you. Let's say we had a question like this: x squared, take away 3x, take away 4. And I said factorize. Well, you would go and factorize it as a trinomial, and you would look at this number 4, and you would do all of that stuff that we've learned about with trinomials, right? And you should eventually end up with that. Okay, you can test me on that. You can just multiply it, or you can just, if you want, you can just take this. you can do a little side part of it over here on your paper, and you can multiply that together, and you'll see that you'll get to this part over here. Now, what would you do at this step? What would you do next? Well done if you said you'd go x minus 4 equals 0, or x plus 1 equals to 0, and then you would solve x is equal to 4, or x is equal to negative 1. So when you are at this step, don't go back up to there, rather keep going. So all we're going to do is we're just going to say x minus 1 is equal to 0, or x plus 2 is equal to 0. And so if you solve, x would be equal to 1, or x would be equal to negative 2. So x is 1 or negative 2, and so the answer is B. What is the volume of a cube with the side length equal to 7? Okay, so with volume, what we must remember is that there is most of you probably know that the volume of a cube is just length times breadth times height, right? I think most of you know that, so let's just go with that. So with a cube, all three dimensions are the same, so everything is 7. So your height is 7, your breadth is 7, and you could call this your length is 7. So with the volume of a cube, you're just going to say length times breadth times height. And so you're going to end up getting 7 times 7 times 7, and that'll give us 343. And then obviously you would have centimeter cube. Transformation. Okay, so the transformation of ABC, this triangle over here, to DEF is called, okay, now we've gone through this where we've spoken about reflection, reduction, enlargements, translations. So let's try to see. They definitely are not making it any smaller. You can see that this shape from A to B is 2 blocks down, or 2 big blocks. You see that? And then here it's also 2 big blocks, and then 2 big blocks across, 2 big blocks across. Okay, so they haven't made it bigger or smaller. So it's not a reduction, and it's not an enlargement. It's not a reflection. If you do a reflection, let's say you did a reflection across, let's say you reflected it across, I don't know, maybe you reflected it across here. Then when you reflect it across, what you would end up with on the other side is an image that does something like this, right? It would flip over, okay? So this is definitely just going to be a translation. They just slide it up or down, or up and up, down, left or right, or something like that. So they're just moving it. So they moved it 1, 2, 3, 4, 5, 6, 7 places to the right. That's what they did here. 1, 2, 3, 4, 5, 6, 7. Yeah, it was a 7 units to the right translation. So this point also went 7 units to the right, and this point also went 7 units to the right. So the answer is D. So with this question, it says that the next number in the sequence is, okay, now have a look at this carefully. Do these numbers look familiar to you? Well, we know that we get square numbers. What are square numbers? Well, what is 1 squared? Well, that'll give you 1. What is 2 squared? That'll give you 4. What is 3 squared? That'll give you 9. 4 squared, 16. 5 squared, 25. 6 squared, 36. 7 squared, 49. 8 squared, 64. 9 squared, 81. 10 squared, 100, for example. Okay, so here we've got the first one. We've got this one over here. Then they skip this one, and then we've got that one. Then they skip this one, and then we've got that one. So then what they're going to do is they're going to skip this one, and then we would have that one. So the answer is C. Which 3D figure has 5 faces, 5 vertices, and 8 edges? Okay, well, let's go have a look. So if we look at a cylinder, so a cylinder is like a toilet roll, okay, or like a Coke can, whatever, okay. So it doesn't really have edges, right? Well, it definitely isn't going to have 8 edges. So we'll immediately cross out that. Now, a dodecahedron, let's not even go there. So let's not try to draw that right now. Let's go to this one, which is a square-based pyramid. Now, think about that carefully. Some learners look at that and they panic, but it's a square base. So let's go draw a square. Okay. So square, and then it's a pyramid. So you're just going to go up, 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 and up. Okay, so there's your pyramid. Now, let's see how many edges it has. Well, it's got an edge over here. That's 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that's looking good. Now, so it's got 8 edges. Fantastic. Now, let's quickly see how many faces it has. A face is like a side. So we've got this whole side over here, which is 1. Then you've got this one over here, which is 2. You've got this one at the back, and you've got this pyramid on the side, this pyramid face on the side, so that's 4. And then if you had to pick the pyramid up, you also have the square at the bottom. So that's got 5 faces, so this one's looking quite good. And then a vertex is like a corner, okay? So it's got 1, 2, 3, 4, 5. So it's definitely going to be C. Why is triangle ABC? Now, I'm not going to say what that means just yet. And then DCB. So you need to know that if it's 3 lines going that way, can you see that that almost looks like the letter E? So that's in the word congruence, we have that. If it was 3 words like this, or 3 lines like that, then it's similar. So similar, or however you spell similar, whatever, but it's got eyes. Can you see there's eyes over there? And there you would have eyes as well. So this one's definitely congruent. Okay, now with congruent, remember we've got different ways for things to be congruent. We've got side, 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 angle, side. We've got like angle, angle, side, for example, and then RHS. So let's go see these 2 triangles. So it is triangle ABC. So ABC and triangle DCB. Okay, so can you see that both of those triangles have the same side BC? They both have a BC, okay? So they've definitely got a side in common. Now they also tell us that this side and this side is the same. So that's another side that they have in common. And then they're trying to tell us that this angle, which is in the yellow triangle, is the same as this angle, which is in the blue triangle. Okay, so we've got an angle. So it's and then it's going to be something then with a side, an angle, and a side. So it's not that one, it's not that one, it's not that one, because that's 2 angles. So then it must be this one: side, angle, side. And what's important, I don't know if you can remember, but when you are busy with side, angle, side, the angle must be in between the sides. And that is correct for this diagram, because let me show you the yellow one. We can see that we used this side and we used this side over here. Okay, we used this side and we used this side over here when we were busy figuring out which things are the same. And then this angle is directly in between them. Can you see that? It's in between these 2 sides. If I show you on the blue triangle, which is this one here, then what we can see is we used this side and we used this side, and then there we've got the angle directly in between them. This question says, what will the probability be if an odd number is picked from a list of numbers from 1 to 13? Okay, so you've got the numbers 1 to 13 scattered out in front of you. And it says, what is the probability that you pick an odd number? So the odd numbers would be this one, this one, this one, this one, this one, this one, and this one. So out of 13 numbers, how many is that? 1, 2, 3, 4, 5, 6, 7. So there's a 7 out of 13 chance that if someone told you to pick a number, you would pick an odd number. Simplify the following. Okay, the first thing I would like okay, there's actually multiple ways you could do this, right? You could try simplify this part first, and then you can simplify this, you can do this part and this part individually. You could simplify those as much as possible. For example, this one's got some P's, this one's got some Q's, so they can cancel, and then you could do the same here. But what I'm going to do instead is I'm going to take care of this divide sign. What do we know about that divide? We know that when you have a fraction divide by another fraction, then what we do is the KCF. It's almost like KFC, but it's just a little different. You keep the first one. That's what the K stands for. You keep. Then you change the sign over here, and then you flip the second fraction. So you keep the first one, you change the sign, and then you flip the second fraction upside down. Okay, now, as we said, there are multiple ways we could now do this. So let's quickly talk about this one over here. Let's quickly remind ourselves how to do this. So if you have 4p squared q over pq3, you must remember that what is p squared? It actually means that there's two p's. So it actually means pp and pp. I actually, this year, in the beginning of this year, 2023, I went to, from February to about April, I went to Thailand, and there is a beautiful island called the PP Islands. I went to many, many islands. I was traveling solo through Thailand by myself, and I went to the PP Islands, which is a beautiful island with blue water. And yeah, I'm not sure if any of you have ever been to Thailand or to the PP Islands, but yeah, it was absolutely beautiful. Okay, but let's carry on. So we've got Q3 over here. So that means there's three of them. Q. Now all that you do is you can imagine we're just going to cancel. So this one can cancel with that one. This one can cancel with that one. And that's all that we can do. So if we had to come back here now, what we would simplify this to is we still have a 4. We still have a P, and at the bottom we have two Q's, so we can say Q squared. Now you don't want to have to do it like this the whole time. You want to be able to just be able to look at this and say there's two P's at the top and one P at the bottom, so there will be one P left over after we've cancelled. Then with the Q's, there's 1 at the top, 3 at the bottom, so that means there would be 2 left over at the bottom, right? Now, if we had to look at this one, there's 2 P's at the top and 1 P at the bottom. So once you cancel them, there should be 1 P left over at the top. With the Q's, there's 3 of them at the top, 1 of them at the bottom. So after you cancel, there should be 2 of them left over at the top. And then there's a 10 at the bottom. Now, there's multiple ways you could go from this step. Sorry, let's put equal here and equal here. Now, there's multiple ways you could carry on. What some learners would like to do is, remember when you're multiplying, these little arrows can help you to remember that you can cross cancel, okay? So you could cancel, for example, like that. You could cancel like, oh no, there's nothing like that. But what some other learners like to do is they will multiply the tops and the tops together and the bottoms and the bottoms together. Both methods are correct, and you're going to have to do both of them anyways. Well, it doesn't really matter. Like, you're going to get the same answer, okay? Mathematics would be horrible if, based on which method you use, you get different answers. That's not the way maths works. Maths is amazing. Whatever method you choose, you should still get to the same answer. Okay, so what I'm going to do is I'm going to multiply the tops and the tops together and the bottoms together. So if I multiply these together, I end up with, let's write it over here, I end up with 4. Now there will be 2 P's, right? Because P multiplied by P doesn't give you 2P, it gives you P to the power of 2. And then there's a random little Q squared. Okay, there we go. Now at the bottom, we have 10Q squared. Okay, now, if you look at the top, there's 2 P's. Some of you are like, no, Kiev, there's 4. No. That 4 is its own thing. We don't combine them, okay? So there's a P, there's 2 P's at the top, and there's no P's at the bottom. So in the final answer, there will still be a P, okay? We're still going to handle the 4, don't worry, we'll get to that now. Now at the top, you have 2 Q's. At the bottom, you have 2 Q's. So they will cancel each other out completely. So there will be absolutely no Q's. Do not put a Q here or a Q here. Some learners do that because they say, oh, there's no Q's, so I'll just put 1 there. But there's nothing. There's absolutely no Q's. And then at the bottom, there's a 10. Okay, now, these numbers here, they are not the same as exponents. So what I want you to do here is just say 4 over 10, and I want you to simplify that. So you could type it on your calculator, or you could just think about it. What number can go into both of these? Well, the number 2. The number 2 goes into this one twice, and the number 2 goes into here 5 times. So we're going to say 2p squared over 5. And that is your final answer. With this question, the first thing I want to tell you is that you must not cancel. You mustn't do something like this. You mustn't go cancel, cancel. Please don't do that. Why can't you do that? Well, you see, there's a very big difference with, let's say I gave you 3xy over 2xy squared. Now, in this type of scenario, how many terms do you see at the top? Well, there is 1 term. How many terms do you see at the bottom? There is 1 term. When you have only 1 term at the top and 1 term at the bottom, then you can cancel. So then you could, for example, say that this x can cancel with this x. Now, some of you might say, yeah, but Kev, doesn't this mean there's 3 x's? No, it doesn't. If there was a x3, then there would be 3 x's, okay? So there's only 1 x there and only 1 x there, and then you would also be able to cancel some of the y's. Now, when you have a situation like this, where we can see there's more than 1 term at the top, remember, when you have a plus or a minus in between, that makes it a new term. So this is actually 2 terms, and this is actually 2 terms. So we don't cancel. What we rather do is we factorize. So if you look at the top, you could take out the number 3. Remember, a common factor is always the factorizing we should try first. So you would take out a common factor of 3, and then you would be left with x plus 2y. And then at the bottom, you've got x plus 2y. Now, when you have a situation like this where this entire part is the same, you see, because if you look at all of this together, you could think of that as 1 term. Because if you look at the 3, and if you look at this bracket, there is no plus or minus in between them, okay? So you could think of that whole piece as 1 term, and this whole piece is 1 term. So you can now cancel that entire part. So you just cancel it out completely, and then you literally just left with an answer of 3. This question says, find the product. Product means multiply. So what they want you to do is take this and then just multiply it inside here. Okay, but there's a couple of places where learners are going to make mistakes here. So when you multiply these two, okay, let's talk about that. So all it does is the 3 and the 2 multiply to become 6, and then the x and the x2, when they multiply, they become x3. Why? Because these exponents are going to add. So this just becomes 6x3. Now, when you multiply this one with this one, notice you're multiplying a positive number with a negative number. So a positive and a negative is a negative. Okay? Now, what is 3 multiplied by 5? Well, that's 15. If you said 8, that's because you're adding and you're thinking of exponents. But you must remember that there's a difference between exponents and normal numbers. So the 3 and the 5, those are normal numbers. So 3 times 5 is 15. Now, what is x multiplied with x? It's not 2x. Because remember, there's a little 1 here and there's a little 1 here. And when you multiply, you add the exponents. So that'll become x2. And then lastly, when you multiply these two together, That's a positive 3 multiplied with a negative 4. So the answer is a negative. Now what is 3 times 4? That's 12. And then there's just a little random x. And that is your final answer. Find the product. Okay, so here we've got 2 brackets. So here's where we would just multiply the 2 brackets together, and that is called FOIL. Well, that's one of the ways we could do it, right? So what does FOIL mean? It means that you first do the first ones. What does that even mean? Well, the first ones would be the first one in each bracket. So that would be this one and that one. So let's go multiply those together. What is x times x? It's not 2x, because when you multiply x with x, there's a 1 here and there's a 1 here. And when you and we've learned that when you multiply these, you add exponents. So that'll become x squared. Okay, now we're going to move on to the O. And I know sometimes I teach this in a different order. There's so many different orders, but I know a lot of learners like to use FOIL. Okay, so the O stands for, let's write this down. It stands for outer. Now what does outer mean? It means that the things over here that are on the outside. So this one's on the outside and this one's on the outside. You see, they are on the outside parts. So it's the negative 4 and it's the x. So when you multiply them, what do they become? Does it become x4? No. It's an x and a 4 multiplied with a 4. So it just becomes a negative 4x. Okay, so we've done the outer. So now we move on to the next category, which is the I. The I stands for inner. So it's the ones that are next to the inner brackets. So it's the 3 and the x. So when they multiply, they just become 3x. And then the L stands for last. So it's the last one in each bracket. So this is the last one, and this is the last one. And so that'll give us negative 12. Okay, now what you do is you just look over all of this, and you see, are there any like terms? Yes, these two are both x. Some of you are like, yeah, but Kev, this is also x. And I'll say, no, that's an x squared. But these ones are only x's, so they are called like terms. So we're going to put them together. So what is minus 4 plus 3? Well, that is minus 1. So what we're going to do is we're going to say it becomes minus 1x minus 12. You're not going to say x squared or anything weird over there, because we're not multiplying anymore. We're just adding and minusing these numbers. Okay? So that'll just stay like that, and that is the answer. Ooh, look at this monster. Find the product of the following. Okay, so the way I would handle this is I would want to get rid of all brackets. Now, a lot of learners are going to make a mistake over here. They're going to just try to put the 2 there, and they're going to try to put the 2 there. But you are confusing that with something like this. Let's say we have this. How many terms do we have over here? That is a 1 term. So in those scenarios, you would just take the 2 and you would multiply it in the front there, and you would multiply it over there. Okay? But when you have more than 1 term, then what you rather do here is you put a double bracket like that. Okay. Then just leave all the rest as it is. Okay. Now we're just going to go use FOIL over here, and we're going to use FOIL over here, but we're going to talk about something important for this part, because something can go a bit weird with that negative. So we're going to go use FOIL over here. So remember, FOIL stands for, I don't always show FOIL. In some of my earlier videos, I used to just use this, and this. But then I realized a lot of learners like FOIL, but you can choose whatever you want, because you do get the same answer no matter which technique you use. Okay, so with FOIL, we start with the first one and the first one. So the first one and the first one. So that would give you x squared. Then the O stands for the outer. So you look at the outer brackets, the brackets that are on the outside, and you take the 2 things next to that. So it's the x and the minus 5. So if you multiply those, what do you get? You get minus 5x. You don't get x to the power of 5 or anything like that. You just get minus 5x. Then the I stands for the inner. So go to the inner brackets, which is those two over there, and you choose the two things next to that. So that's the minus 5 and the x. So that'll give us minus 5x. And then you choose the L, which stands for the last. So you choose the last one over here and the last one over here. So if you multiply minus 5 and minus 5, you get positive 25. Okay, now be careful over here. You're going to multiply these two together, okay? But then there's this minus 1 in the front. So because there's that minus 1, what I want you to do is I want you to say minus 1. Then I want you to open up a bracket, and whatever this answer becomes, put it inside that bracket. Then in the next step, we can multiply the negative 1 inside. Okay, and if this was like a positive 2, you would do the same thing. Okay, so we're going to say first times first, which is going to be x times x, which is x squared. Then outer, so the outer bracket and the outer bracket. Remember, outer means on the outside. Maybe that's a better word. Outside, inside. You see, as you teach, you start thinking of better ways. The O stands for outside. It's the outside brackets, not the outer bracket. I mean, both is correct, but this just seems better. So outside bracket, so it's this one and this one. So you take the two things next to that. So there's an x and a minus 5. So that'll become minus 5x. Then it's the inside bracket. So it's the inside and the inside. So that'll become positive 5x. Then it's the L, which means the last one. So it's the last one over here and the last one over here. So when you multiply positive 5 and negative 5, well, that's 25. But a positive and a negative gives you a negative. And then we're going to say plus 10x. In our next step, I would just like to multiply this negative 1 inside. So that's going to give you x squared, take away 5x, take away 5x, add 25. Okay, now we're going to put the minus 1 inside. So it's going to become minus, you can even say minus 1x squared if you want. And then a minus and a minus becomes a plus. So that'll become plus 5x. And then a minus and a plus will become a minus 5x. And then a minus and a minus becomes a plus. And then plus 10x. Okay, so now we don't have any brackets. So now what we can do is just put all the like terms together. So for example, here we have an x squared, and here we have an x squared. So what is 1x squared minus 1x squared? So if I say, hey bro, how are you? Here's an x squared. And then I'm like, hey bro, can I please have my x squared back? Well, then how much do you have? You have absolutely nothing. So these would cancel each other out. Then we have minus 5x minus another 5x plus 5x minus 5x plus 10x. Okay, that's a mouthful. So minus 5 is minus 10. Some of you are like, yeah, but Kevin, isn't 2 minuses a plus? No, that's only when we're multiplying, which is what we were doing over here. But in this step, we're not multiplying. Now we're just putting like terms together. So we're just plussing and minusing. So you could even take your calculator and you can just say minus 5, then plus 5, then minus 5, and then plus 10. If you've done that correctly, you should actually get 0. Let me just double check that on my calculator. Yeah, so that means there's absolutely nothing. You're not even going to put a 0 there. There's just nothing. And then, so those are all cancelled out. And then you've got 25 plus 25, so that'll just give us 50. And so that's the answer, 50. Factorize. Right, so remember, the first step with any factorizing is to always try to take out a common factor. Only after that would you then start looking at difference of squares, trinomials, grouping, things like that. But step 1, I always want you to try do a common factor. So, if you look at the numbers, just the 3 and the 12, what is a common factor for 3 and 12? Well, that would be 3. The number 3 can go into both of those. The number 3 goes into here once. We could have taken out more stuff, but I'm just doing it in baby steps. And then the number 3 goes into 12 4 times. Okay, so there's our first step. To make sure that we've done it correctly, if we had to multiply this back, don't do it actually, because then you're just going to go back to this. But if you just want to double check yourself in your test, if you multiply these together, you should get 3a squared b3. And then if you had to multiply this back over here, you should get negative 12a 4b. So everything's good there. Now we need to look at the letters. So here we can see we've got 2 a's, and here we can see we've got 4 a's. So you can take out the smallest number, which is 2 a's. So you take out 2 a's, and then here we've got 3 b's, and here we've got 1 b. So we can always take out the smallest number, which is a 1. Now, let's see what we have left. So if you look over here, we had 2 a's, but we've taken 2 a's away, so there's no a's there. Then we had 3 b's, but then we took 1 away, so now we only have 2. So we're going to put a 2 over there, 2 b's. Minus, now we had 4 a's, but then we took 2 of them out, so how many a's do we now have? Well, now we have only 2. And then we had 1b, but then we took out 1b, so then we don't have anything over there. Now, something that a lot of learners do is they forget to, or they get this first step, and then they think they're done. But remember, it's a 3-mark question. That would probably only get you 1 mark. So now what you do is you move on, okay? So we've done common factor. Now we look, what more could we do? So if you look at this bracket over here, it's b squared, take away 4a squared. So how many terms do we see there? Well, that is 2 terms separated with a minus, and each term is a perfect square. Why? Because b times b would give you b squared, and 2a times 2a would give you 4a squared. So this is a perfect difference of square. So we go on to the next step. We say 3a squared b. Then we open up 2 brackets, because remember, that's what we do with difference of squares. And then we put the perfect square. So b and 2a, b and 2a. And then you put a plus in one of them and a minus in the other. It doesn't matter which one's a plus and which one's a minus, as long as you have that. Then you look carefully. We can't do anything there. There's nothing we can do there. And there's nothing we can do there. And there's how we would get our 3 marks. They'll probably give you 1 over here, and then somehow maybe 2 over there. Okay, for a total of 3 marks. Factorize for 2 marks. Okay, so remember with factorizing, we always try to start with a common factor. Then we move on to difference of square, trinomials, and then grouping. Okay, so there's no common term in those 3 over there. It's not a difference of square, because a difference of square only works with 2 terms. So this is actually a trinomial. So with a trinomial, we open up 2 brackets. Now, x times x over there. Now, for this next part, you look at the 10. You don't have to worry about the negative. You just look at the 10, and you write out all the different factors, or the different ways of making 10. You could say 1 times 10, 2 times 5. Now, you look at these 2 different options, and you see which numbers could you combine to make a negative 3. With this one, the negative is important, so you definitely cannot make a 3 using a 1 and a 10. I mean, 1 plus 10 is 11, 10 minus 1 is 9. You're never going to get to 3 or negative 3. But if you look at these 2, there's definitely a possibility to make a 3. How? By making minus 5 plus 2, because minus 5 plus 2 is minus 3. So we're going to say minus 5 and plus 2. That's it. End of the question. Factorize for 3 marks. So with factorizing, we always like to start by looking at a common factor. Then if that doesn't work, we could go down to difference of squares, or trinomials, or grouping. Now, I don't see any common factor over here, but what I can see is that these 2 are almost the same, but they're not exactly the same. If it was a plus, listen carefully, this is very important. if it was a plus, then these two are actually exactly the same. Why? Because when you plus numbers together, the order doesn't matter. Both of these give us 8, for example. But if I say 3 take away 5 and 5 take away 3, this one gives us 2, this one gives us -2. So when you minus, the order actually makes a big difference. So these two are not the same, but we can make them the same by doing a little trick. What we do is we change this sign. So whatever it is, you change it. So if it was a plus, you make it a minus. And then you just change this one. So notice that the A was negative. Now I've made the A positive. And the B was a positive. You see there's a positive there. Now it's a negative. Okay? Mathematically, that is allowed. Now, the reason we did that is because now we have these two being exactly the same. So now it's taking out a common factor. So the common factor is the A minus B. Okay? Now, in the first part, we still have a 4x left over. So we say 4x. In the second part, we have a -3. And that's our answer. We can't go any further. There's nothing more you could do. And so that's it. Solve for x. The first thing I want you to identify is that we have fractions. Okay? So when you have a fraction and you're busy with an equation like this, we need to find a lowest common denominator. So the lowest common denominator between a 2, a 3, and a 1 would be the number 6. Okay? So to make this one become a 6, we will multiply by 3. But what you do to the top, you have to do, or what you do to the bottom, sorry, you have to do to the top. Okay? That's a 3 multiply. Notice I'm putting a bracket because I don't only want to multiply this one by 3, I want to multiply the entire top by 3. Now, for this part, we would multiply by 2. But what you do to the top, what you do to the bottom, you do to the top. And in this one, you multiply by 6, and what you do to the bottom, you do to the top. Okay, so what we now have is this over 6 minus this over 6 equals to this over 6. When we are busy with an equation where we have an equal sign over here, when the denominators are all the same, we can ignore the denominator. So what we actually now have is a simple question that now looks like this. Okay, and so now we just multiply the 3 into the bracket, and so that just becomes a 9x, take away 3, take away 4x equals 12. Okay, if some of you look at something like this and you're like, sir, isn't it going to be 2 times 2 and then 2 times x? No, what you're thinking of is if it looks like that. Okay, and so what we now get is a normal equation, a linear equation. So we will take the -3 over to the other side. And so on the left, we'll just have 9x take away 4x. And on the right, we will have 12 plus 3. It became a +3 because we took it over to the other side. And so now we end up with 5x equals to 15. And then we divide both sides by 5. And so x would be equal to 3. Fellaini sees the following advert. There is a scooter for sale. It's 15,000 Rand for the scooter. But there's also a hire purchase agreement available. Let me explain. In real life, if you go to a motorbike or a scooter shop, you have 2 options when you buy the scooter. Okay? You can either pay for it cash. What that means is that you pay for it with one amount. It doesn't mean you have to go there with a big briefcase with cash. What they mean is you can even use your card if you want, your bank card. But you're paying for it all in one. You're giving the person 15,000 Rand and that's it. You don't need to pay anything more for your scooter. It's your scooter. You never have to pay anything more besides petrol and things like that. Okay? The other option is that you don't pay the 15,000 Rand in one step, but you rather pay for it over maybe 1 year or 2 years. So with that option where you pay for it with 1 year or 2 year or 3 years, you will end up spending less each month, but you will have to end up spending more than 15,000 Rand if you add all of the payments together over the 1 or 2 or 3 years. So you're going to spend, you might spend like 18,000 Rand, but it'll still be easier because you only have to pay a little bit each month. Okay. That is the way that most people do it in real life, because sometimes to be able to have 15,000 Rand in one step can be very challenging. It says here, since he cannot afford to pay cash, okay, he opts for the hire purchase agreement, which says the following. Okay, so he's not going to do this one, okay? He's going to rather do this one. So you have to, okay, now the way that it works is if you walk into a motorbike shop and you tell them, I don't want to pay 15,000 Rand today, I rather want to use hire purchase, they will ask you to pay a little bit today. They're not going to just, most times they're not going to just let you take the scooter and you're not going to pay anything. They're going to ask you for a small payment today, and that small payment is called a deposit. Okay, so the first question says, how much will that deposit be? Well, they said that it's 15%. 15% of what? 15% of the total. So you're going to say 15% of 15,000 Rand. Now, of means multiply. And then with percentage, you can either type it like that on your calculator where you put the percentage button, or you can say 15 over 100. If you had to go and work this out, you end up with 2,250 Rand. So what that means is that if you go buy your motorbike, you walk into the motorbike shop, you tell them, I don't have 15,000 Rand. They say, okay, that's fine. You can do a higher purchase, but can you please give us 15%? So that means that on the day that you buy your motorbike, you're going to give them this amount over here. Okay. Then it says how much, calculate the total amount that he must still pay. Okay, now that question could have been taken a bit in different ways, but it's a 3-mark question. So they're not saying how much must he still pay from the 15,000. They're talking about how much must this person now pay after they've done the interest. You see here they're doing 10% per annum. So that is you can think of the interest as like the penalty because you're not buying the motorbike cash. Remember I told you that you're going to end up spending more than 15,000 Rand, and that is because of something called interest. These shops would never let you take the scooter and pay it off over 2 years without making the price a little bit more. Otherwise, it's easier. Yeah, they rather add interest so that it makes it better for them. Okay, why would they give you the scooter for 15,000, but they tell you that you can pay it off over 2 years? They'll rather say that you can pay it off over 2 years, but then they're going to charge you interest. That's how that makes it more worthwhile for them. All right, so what we need to understand is that the scooter was 15,000 Rand. Okay, 15,000 Rand. How much have we already paid? Well, you've already paid 2,250. That was your deposit. So how much is still left over? How much is this amount over here? Well, that would be 15,000. Take away 2,250. And that'll be 12,750 Rand. The person at the shop is going to take that number and they're going to use this formula over here to see how much the new amount will become. So they're going to take the 12,750. They're not going to use 15,000. They're only going to take the amount that you still have to pay, and they're going to put the interest, because that's the part that they still need you to pay. Then they're going to put the interest on that. So they're going to put interest of 10%. So that's 10 over 100. And then the number of years is going to be 2, because 24 months is the same as 2 years. So I need to change this to years because this is years. Okay. If you had to go work this out, it'll be 15,300 Rand. So calculate the total amount that he must still pay, 15,300. Okay. Then it says, what is the monthly installment? Well, the person has to pay this amount over 24 months. So you just divide that by 24, and that'll be 637 Rand and 50 cents. You see, it's easier to rather spend 637 Rand and 50 cents every month for 2 years instead of having to pay 15,000 Rand at once. But remember, you are going to end up spending more for the motorbike. You're going to spend this amount and you're going to spend this amount. So if you had to add those two numbers together, you're actually going to spend about 17,550 Rand. So you are paying more. But it's easier because you only have to pay that per month. Bongiwe invested a certain amount of money into a savings account using compound interest. If the final amount is that, how much did she originally invest? Okay, so this is the compound interest formula, which goes like that. Now remember that this is your final amount. This is your starting amount. But we don't know what the starting amount is, so we can just call it X, or we can just call it P. But we know that the final is 15,300, so we can do that. Then we can do that. The interest is 6.5%, so you could say 6.5 over 100, which is actually just 0.065. The number of years is 5. Okay, so the way that you can get P by itself is you just take all of this to the other side. So can you see that in between here and here, there is a multiply. So to get rid of it, we divide. So you're going to end up going like this. Okay, and then you can just go type all of that on your calculator. And you should get 11,000 Rand, 167.18 as your starting amount. And then, by the way, for any of you who have the memo of this exam paper, you'll see that they got 12,000. Now, I can promise you, I see mistakes on memos all the time, and I looked through this one very carefully. I promise you that 12,000 is absolutely incorrect. This does happen a lot, okay? This is what I do for a living. I see mistakes on memos many times, okay? So I promise you it's not 12,000. Write down the next term in the given sequence. Okay, so what we can see is that we're going 3, 8, 13. So if you look carefully, we're adding 5 each time. Adding 5, adding 5. So the next term, you would add 5, and that would become 18. Then it says, describe the pattern in words. Okay, so for that one, we could just say, you could literally just say add 5. So to go from the next one term to the next term, you just add 5. Question 4.3 says, write down the general term of the sequence. Okay, so when you have a linear sequence like this where you're just adding the same amount, to make a formula, all you do is the following. You just say Tn equals. Now, how much are they adding each time? 5. So you just say 5n. Now, if it was a negative number, then you would say negative 2n. For example, if we had the sequence 8, 6, 4, 2, then you see how they're going negative 2, then you would say minus 2n. Okay, now the next step is, to modify this formula is, if you look over here, this is called term number 1. What would term number 0 be? Term 0. Well, you would just go back by 5, and would you agree with me that that would be minus 2? Make sure you understand that it's minus 2, and then I just want you to put that over there. And that is the formula, okay? That is how you find the formula. All you do is you use the 5, tells you that how much you're increasing or decreasing every time, and then this number will just be term 0, okay? Now, this question is very important. A lot of learners will make mistakes with this next one. Which term is 38? So you've got to think about this very carefully. If I give you a random sequence, let's say, or actually let me use the one that we have here, 3, 8, 13, 18, 23, 28, 33. Now, if I look at, for example, this one, that's 1, 2, 3, 4, 5, 6. So we will say term 6 has a value of 28. We could say term 7 has a value of 33. Now, what's important is that this part here is the value, and this part here is the term number. Okay, so they said which term has a value of 38. You could think of it like that. Which term has a value of 38? So where would the 38 go? Would it go here or would it go here? Well, the value is 38. So you would say 38 over here. Then the term number, we don't know. We don't know which term is 38. Okay? You could probably work it out just by looking at, if you had to go to the next term, it would be 38, right? But they want us to calculate it for 3 marks. And so now you're just going to go calculate it. So you take this minus 2 to the other side. So it'll become 38 plus 2. And so you end up with 40, like that. And then you divide both sides by 5. I'm running out of space here. And so you end up with 8 is equal to n. So that means that if you had to go to position number 8, let's see. This is position 1, this is position 2, this is position 3, this is position 4, 5, 6, 7. And then the next one is position 8, which would have a value of 38. Study the graphs below. Alright, so what we have here is we have an x-axis and a y-axis. And then we've got a line which has the equation y equals x. And then we have another line. Well, that's a bit of a... Let's go with like something lighter like that. Okay, then we've got that line over there. Now, the question says, what are the coordinates of P? So P is the intersection of these two graphs. Okay, so P is this point over here. Now, what we can see is that this point is a 3. They mean this point over here. They haven't shown that very clearly. But this point here is a 3. But now, you got to think about that point carefully. Every point has an x and a y. So this one's x would be a 0 because it's not left or right. It's on the y-axis. So it will have a 0 for its x value. And then its y value will be 3. Now, if you go anywhere on this line, either that way or that way, would you agree with me that the y value will remain 3? Remember your y value. For example, if I have an x and a y here, and I have this point over here. Now, let's say this is the coordinates 2. So the x is 2 and the y is 3. Then if you have a point over here, maybe the x will be minus 1, but the y will still be 3 because it's 1, 2, 3. You can see that it's 3 places up. So everywhere on this line, can we agree that the y value will be 3? Okay. So then they said, what is the coordinates of P? So we already know that P has an x and a y. P has an x and a y. We don't know what its x is, but we've just worked out that the y must be 3 because anywhere on this line, the y value must be 3. Okay, now you see that this point is on this line over here. Now that line has an equation, and that equation tells us, or what we can do is we can tell this equation that there is this point P, which is on this line, and we know that point P has a y value of 3. So we can go to this equation and we can put the y value as 3, and then look at that. We now have the x value. The x value is also going to be 3. So then we can say that the x is 3 and the y is 3. If this equation was a little bit different, let's say it was something like y equals to 2x plus 4, then you would use the same approach. You would take this y value of 3, and you would just plug it in over here, and then you would simply go and solve for x. Okay, so that's how you approach a question like this. So the answer will be 3 and 3. On the Cartesian plane below, the graph y equals to minus 2x plus 4 is shown. Okay, so this line has the equation minus 2x plus 4. First question. On the annexure provided, draw the straight line graph represented by this equation. Indicate all of the intercepts and label your graph CD. Okay, so they told us that the equation is y equals to minus 2x minus 4. Now, an easy way to draw a straight line is to go find your x-intercept. How do we do that? We make y 0. And then the other thing we need to do is we will go find the y-intercept. How do we do that? You make x 0. So we'll begin on this side over here. So we make y 0. So what does that mean? You literally just go to this equation and you make y 0. So you make y 0 and you're just going to go solve. So you can do this however you want, but I'm going to take the negative 2x to the left, so it becomes positive. Then I divide both sides by 2, and x would be equal to negative 2. So look at this carefully. X is negative 2, and y is 0. Go find that on the diagram. X is negative 2, and y is 0. That would be over here. Okay, now let's do this one. So now we restart, put our equation. And now, don't mix these two, okay? We're now restarting, so now you're ignoring this part. So now we're going to make x 0. And so you end up with 0, take away 4, which is negative 4. So then you go put x is 0 and y is negative 4, which is over here. Some learners, what they do, actually a lot of learners do this, is they take these two values and they put them together. But that's not what you want to do. You want to put this one and this one together, and then you want to put this one and this one together. Now you've constructed 2 points, and so now we can construct a straight line. Obviously you would have a beautiful ruler to use, and it would look like that. This last one says, what can you deduce about the two graphs? Oh, we must label this CD. Give a reason for your, C and D. Give a reason for your answer. Well, what we can say is that they're parallel. Parallel is when it looks like a railway line, right? And when two lines are parallel, they have the same gradient. Now, if you look carefully, this one has a gradient of minus 2. Remember that when your line is written like this number here is the gradient. Now, if you look at this one, it's the same. It also has a minus 2 in front of the x. Can you see that? So that's the gradient. So when they have the same gradient, they are parallel. So we can say here parallel, and then just say same. You can say same slope or same gradient. In the figure below, ABC is a straight line. Angle B2 is 75. Angle B3 is 55. This is very easy, hey guys. Determine the value of x. Well, we know that on a straight line, the angles add up to 180. But some learners do get this confused. For example, if I gave you a line like this and I put something there, and then I put something there, and then I say that this is 150, and this is 10, and then this, then some learners, they don't know if we must add all of these together to make 180. So how does it work? Well, you see, wherever you've got this part coming down here, I want you to think of that as that's a section, and then you've got another line coming down, so that's another section. So each of those sections must add up to 180. Okay? So if there was something else over here like that, then this part must add up to 180, but then this would be another section that must add up to 180. So this is by itself. Okay? So all three of these must add up to 180. Now, we can't just say that. We have to go do it properly with a reason. So we could say that angle x must be equal to 180 minus 75 minus 55. What's the reason? That is because these are the angles on a straight line. Then if you had to go work out x, you would end up with 50 degrees. In the figure below, CS is parallel to HN. As soon as you think about parallel, you should be thinking about fun. F for corresponding. Remember, we've spoken about this, right? With corresponding, whenever you see an F, these angles are the same. Then there's the U. The angles inside a U, let me draw a U that's a little bit skew. Can you see that this angle is not the same as this angle? So with the U, the angles are not the same, but they do add up to 180, okay? They add up to 180. And then the N or the Z, you could also look at it as a Z. Then the angles on the corners, they are the same. Inside the corners, they're the same. Okay, so it says in the figure we've got parallel lines. Now, so remember, as soon as you see parallel lines, fun. Okay, fun only works with parallel lines. They tell us that EAW. So some learners get confused with what this means. So let me show you. So it says start at E, go to A. Then from A, go to W. Then the angle that is made is the one that they're talking about. You see how it's angle A, and that's why they've got a little thing on the A. Okay, so telling you that this angle here is 70. AE has the same length as AW. That's what they're trying to show you with these lines. And then CAE, now look at that, C, so where's C? There it is. Go to A, then from A, go to E. The angle that you made is X. So the first question says, give a reason why angle E2 is also X. Well, you see, if we do that, then what shape have we just made? That's a Z. And what we know is that the Z, the corner angles are the same. So this angle must be the same as this angle. So that is why E2 is the same as X. So the reason is alternating angles. So you'll just say alt angles, and that is because the line CS, whoa, that's a D, Kevin. CS is parallel to HN. So we're saying that alternating angles. Remember, the Z or the N is called alternating. Let's recap. Okay, alt. And then the F is corresponding. And then the U is co-interior, like that. Okay. So, the next question for 3 marks, determine the value of X. Okay, so we know that this is now X. The next thing is that when these two sides are the same, then I want you to remember this. Listen carefully. When two sides of a triangle, actually, let's make some notes. Here we go. When two sides of a triangle are the same, then two of the angles are the same. Then when 3 sides, by the way, this is called an isosceles triangle. Isosceles. Now, when 3 sides of a triangle are the same, then 3 of the angles are the same, and that is called an equilateral triangle. And then lastly, when all 3 sides of a triangle are different, then no angles are the same. So what we know from this triangle is that these two sides are the same. That is what these lines are trying to tell us. So if these two sides are the same, then the angles opposite them are the same. So opposite this side is that angle over there. So that is W1. And then opposite this side is this one over here. So that's E2. So what we can then say is that these two angles are the same. So that'll be our first step. We will say that angle E2 is the same as angle W1. And that is because they are the angles. They are the angles that are opposite equal sides. Listen to that carefully. These are the angles that are opposite equal sides. That's why they are the same. So then we can put an X over there. Now, check this out. We know that this is a triangle. Okay, and we know that the three angles inside a triangle must always add up to 180. So what we can do is we can say that 70 plus X must add up to 180. And that is because the sum of the angles of a triangle. And so that'll give us 70 plus, now X plus X is 2X. Now we have an equation. So with an equation, we'll take the 70 over to the other side. So it will end up becoming like that. And then I'm going to go up here. So that'll end up giving us 110. Divide both sides by 2. So X will be 55 degrees. A, B, C, D is a parallelogram. Calculate the size of B. Okay, so let's have a look. Now, obviously, it's very important that you understand your parallelogram properties. One of the things we should know about a parallelogram is that the opposite angles. Now, remember, I don't want you to just memorize this. Think about this. Can you see this angle? Can you see the size of it? Don't say 2x minus 20. Forget about that. Just look how big that angle is. Is that the same as this angle? Well, no. Look how big this one is. Think about these as your arms. Now look how wide your arms are over there. And then look how closed your arms are over there. So that's not the same. But if you look at the opposite angles, look at your arms over there. And then look at your arms over there. Can you see that they are the same? So these two are the same as each other. That is the way a parallelogram works. That is one of the properties of a parallelogram. So what we can say is that angle B is the same as angle D. And that is because those are the opposite angles of a parallelogram. Now, there's different ways of writing parallelograms. Some teachers do it like that. Some teachers say palm, which means parallelogram. So you must just obviously do what your teacher does, okay? Or whatever you are comfortable with. So that means that angle B is also 2x minus 20. So let's go fill that in. 2x minus 20. The next thing is that these two sides are parallel, right? Because it's a parallelogram, so they are parallel. And so whenever we think of parallel, we should think of F, U, and N. So fun, right? So what shape have I just highlighted? Well, that is a U. Now, remember, when you are looking at a U, let's draw a skew U. Do these two angles look the same? Think of these as your arms. So if these are your two arms over here, okay? So look at those. And then in a different situation, look at those. Are your arms open by the same amount? Like, think of these as your hands. Here's your hands. Whoa, what happened there? Just cut your arm off. And then here's your other hand. Whoa, Kev, what's going on here, bud? Okay, so there's your hands, right? Look at how your arms are opened up, and then look at there's your hands, and there's your hands. So can you see here your arms are much more opened up? So we cannot say that these two angles are the same. So when it's a U, remember we've got the F, we've got the U, and we've got the N, or the Z. Whenever it's a U, the angles are not the same, but there is something special about them. Well done if you remember that they add up to 180. So these two angles are not the same, but they must add up to 180. So we can say that angle A plus angle B must add up to 180. Why? Because they are co-interior angles. The reason that we are allowed to say that is that AD is parallel to BC. Okay, now all that we need to go and do is just go replace A and B with whatever they are. So A is this, so we say x plus 50, and B is this, and then we just say that. Now it's just a mathematics equation, so we can put the x's together. So x plus 2x is 3x. 50 minus 20 is 30. Now we're going to take the 30 to the other side, where it becomes a minus. And so now we have 150. Now we will divide both sides by 3. So x is 50. Now, a lot of learners, they say, oh, cool, I'm done. Next question. But the question said, calculate the size of B. The question did not say calculate X. So if you look at B, B is actually this. So B is then going to be 2x minus 20, but X is 50. That's what we've just calculated. So that means that B would now be 100, because that's 2 times 50, minus 20. So B would be 80 degrees. In the figure below, AB is equal to AC. So you see how they told us that they're equal in length, and then they also showed it to us like that. So those two sides have the same length, okay? And then in another scenario, BD is the same as CD, and we can see that they are the same because they've got those. The reason that these ones have one line and then these ones have two lines is just to separate everything. Because if this one only had one line, then it would mean that all 4 of those are the same. But that's not true. The first question for 4 marks is a congruency question. How do I know that it's congruency and not similarity? Well, it's all in the word. If you want a little trick, which I've obviously shown you this before, but let's remind ourselves. Similarity. Okay, so in the word congruency, we've got an E. Now that E has 3 parallel lines. See that? And there they are. You could imagine that that's an E. So, and then similarity has 3 lines going like that. Similarity. So, similar would be like that. So this is definitely congruency. Now, when you think about congruency, I want you to think about side, 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 angle, side, angle, angle, side, and RHS. And then remember, what does congruent mean? Exactly the same. So let's see how we can do this. We can start off by saying, in triangle ABD, which is this one, and triangle ADC. Okay, so let's go find 3 things. So remember, we always have to find 3 things. So the first thing we can find is that AB is the same as AC. We're just finding 3 things that are the same in both triangles. So the reason for that is given. They gave us that. They told us that. We didn't have to go do anything. They literally told us that. The next thing is that these 2 are the same. So we can just go say BD is the same as DC, and that was also given. Now, What's the third one? Because remember, we need three things. Well, that's actually quite easy. Check this out. This line is actually a boundary between the two triangles. So if we had to pull the two triangles apart, you would get something that looks like this. That would be triangle BAD. And you would get this triangle over here. ADC. But the point I'm trying to make is that you would have AD in both. So this side is a side for both triangles. So we could say that they are the same as each other, obviously. But now you won't say given, you would rather say common. They are, if you go outside, let's say you have a house, right, outside. Or you have a house that you're living in right now, but you have a garden and you have a wall. Now, if you go outside and you have a wall and you have a neighbor, do you and your neighbor have the same wall? Yes, that's called a common wall. It's common to both houses. So it's common. Now, there's 1, 2, 3 things. Fantastic. So what we can then do is say, therefore, these two triangles, now just use the order that they gave you, is triangle ABD is congruent to triangle ACD. Now the reason will be, well, what is this? Is this an angle or a side? That's a side. Is this an angle or a side? That's a side. Is this an angle or a side? That's a side. So that would be the SSS. So you're just going to say SSS. That's how you do it for 4 marks. Then this last one says, hence, prove that DA, so DA is this one over here, bisects BAC. So now where's BAC? Well, to find BAC, you start at B, then you go to A, and then you go to C. There we go. Now, let's talk about this a little bit further. Because I know that when I was in grade 9, these kind of questions confused me. Like, what does bisect mean? And maybe you know what it means. You're like, yeah, okay, if it means cut in half. But do you really understand it? So let's talk about that a bit. If we have a situation like this, and here we've got an angle 30, and here we've got an angle 70, then does this line bisect this angle? Well, no, because the word bisect means to cut in half. So these two are not the same. So it's not cutting it in half. To cut something in half means that this would be 50, for example, and this would also be 50. So these two parts would be the same. So what they are saying is prove that DA, this line, cuts this angle in half. So they wanted us to show that these two are the same. Now, why would they be the same? Well, think about this. We've just proved that this triangle is exactly the same as this triangle. So that means that these two parts have to be the same. So we can say that triangle ABD is congruent to triangle ACD. Why? Because we've proven that. Then you can say, therefore, angle A1 has to be the same as angle A2. And that is all you say. In triangle PQR, which is that one, and triangle STR, which is that one, PR is 10, ST is 3, and SR is 6. Okay, so they've given us that. Then it says, for 4 marks, show that this. Okay, now, they said PQR, and then they've got 3 lines going that way. Okay, now, do those 3 lines mean congruent, or do those 3 lines mean similar? Well, it would definitely be similar. Why? Because remember, in the word congruence, we can see there's a E over here. So congruence is when they say that. Whereas in the word similarity, there's 3 I's. 1, 2, 3. And so the lines go that way. Okay. So we are definitely busy with similarity. Now remember, what does it mean when two triangles are similar? Similar means that they're not exactly the same. It means that it maybe looks like this. It's like this one is a smaller version of this one. So when two triangles are similar, when are two triangles similar? Well, there's two ways to show that two triangles are similar. The first way is to show that all corresponding angles are the same. For example, if this is 40 and this is 40, this is 70, then this is 70, or let's actually choose a different number. Let's say 60, then this is 60, and then this would have to be 80, and then this would have to be 80. So if those are all, you see how these two are the same, and then those two are the same, and then those two are the same. So if that happens, then they are similar. What do I mean by corresponding? I'm just saying all the matching angles are the same. Show that all corresponding, angles. So these two are the same, those two are the same, and those two are the same. The other way to do it is show that the sides are in proportion. What does that mean? Well, let's say, for example, let's actually go back here. So now we're not using angles, now we're using sides. So let's say, for example, this is a 3, this is a 6, this is a 7, this is a 14, this is an 8, and then this would be 16. Have a look at this. If you say 3 times 2, you get 6. If you say 7 times 2, you get 14. And if you say 8 times 2, you get 16. So can you see that this one is double this one? So can you see that all of the different parts are double, okay? That is what we say that all the sides are in proportion. So, we're not going to use the sides in proportion for this question because they haven't given us all of the sides. Can you see that? They haven't given us enough sides to be able to go and see if all of them are in proportion. So we're going to use angles because they gave us these parallel lines, and whenever they give us parallel lines, it unlocks some amazing features for us. It unlocks fun, or fuzz if you have a Z. So whenever you have parallel lines, then let's rather use the U like that. Then we must remember that we've got these things that we can use. So what we're going to do, remember I said there were two things here. I said that we could either use angles or sides. And when I said angles, I said all of the angles, the corresponding angles must be the same. So let's go see if we can make the angles the same. So for example, we know that this angle, this is meant to be R2 over here. I don't know why that was like that. We know that these two angles have to be the same, this one and this one, because of vertically opposite angles. So we can say, let's just say in triangle PQR and STR. Okay, so we can say that angle R1 must be the same as angle R2. And that is because they are vertically opposite angles. Okay, the next thing is that if you look here, can you see the Z? So what we know from a Z is that the corner angles are the same. So that's this angle and this angle. So we could say that angle P is the same as angle S, and that is because these lines are alternating. So we could say alternating angles, and that is because the side QP is parallel to ST. For the next one, there's two different ways you could do this. You could either use parallel lines again by going that way. So you could say that these two are the same. Your other option is that, well, yeah, I think that's actually the best one. For those of you that want to try another way, you could also say because of the sum of angles in a triangle. But if that doesn't make sense, then just ignore what I just said. So let's block this out. So we're going to use parallel the other way. So we're going to say Q is the same as T, and it's the same reason. QP parallel to ST. So there we've done it. We've showed all three angles. We're not saying that all angles are the same. We're just saying that those two are the same. Those two angles are the same. So this one and this one. And then we're saying those two angles are the same. So all of the matching ones are the same. So therefore, the two triangles, PQR, are similar. And the reason is because, why? Was it all the sides? No, it was all of the angles. Angle, angle, angle. Then, now, remember, this is important. Are these two triangles now similar? Yes. And what did we say about similar triangles? Remember, I wrote it over here earlier. Let's take all of this away. We said when two triangles are similar, then, number one, or corresponding. Well, let's rather use the word matching, because when I say corresponding, some of you might think I'm talking about this, because the F is also corresponding. All matching angles are the same. Number two, all matching sides, they're not the same, but they are in proportion, For example, remember if I have two triangles, and this is a 3, this is a 6, this is a 7, this is a 14, this is a 8, and this is a 16. We're not saying that they're all the same, but we're saying that they're all in the right proportion. Can you see that this one is double this one? Okay? So, we just proved in this question that these two triangles are similar. So that means that both of these are true. So now we can go to this one. And all the matching sides are in proportion, because these two triangles are similar. Now, to work out your proportions very easily, you're going to take this, okay, and you're going to make some proportions. What do I mean? Take the first two letters, and then take the first two, then take the second two, and take the second two, then take the first and the last, and then take the first and the last. Then what I want you to do, well, we actually have to give a reason for what we just said over here. The reason is that the triangles are similar, but your teacher, there's so many different ways of teachers writing this. You could use, so just see what your teacher says. Some teachers will just say proportional over here. Some teachers will say corresponding. They'll say it's because these triangles are similar. So they'll say similar triangles. Or some teachers will say corresponding sides in proportion. So just check what your teacher says. Okay, I know that on this memo they say proportional. Okay, so now go fill in whatever you can here. So PQ, do we know what PQ's length is? No. Do we know ST's length? Yes, we do. So that's 3. You don't have to say 3 centimeters, just say 3. QR, we don't have. And then TR, we don't have. And then PR is 10. And SR is 6. Okay, now, I don't want you to choose this one. This is an ugly one. Why? Because we don't know two of the things. So leave that one out. Just leave it out. Just ignore it completely. Now you just have that. So we're just going to say PQ over 3 equals to 10 over 6. Now, when you get a situation like this, all I want you to do is do cross multiply. So multiply these two together and then multiply these two together. So 6 multiplies with the PQ and 10 multiplies with the 3. So you end up with 30 over here. Then you get the PQ by itself by dividing both sides by 6. And so PQ is 5. And there we worked out PQ. Study the diagram below and use the annexure. Reflect the object about the y-axis. Okay, so here's your y-axis, remember? Okay, so what it means is just jump. So they want you to jump. So you're going to take this one and you're just going to jump it over this line. So the way it works is, if you look here, there's 1, 2 blocks. So you jump, it jumps twice. So you jump twice on the other side. So that'll be the new B. Then for A, can you see that it's 1, 2, 3, 4? So you're going to jump 1, 2, 3, 4 on this side. That'll be the new A. And then C will end up going over there. And then just connect all the dots. There we go. So that's this question. Now it says write the rule. Okay, so the rule's very easy. I don't know why that's popping up. So the rule is very easy. All you do is you just say x, y. You just copy what they're doing here. And then you say goes. Now we've got to try to figure out what happens. So if you look at A's coordinates, let's quickly fill in A's coordinates. It has an x value of -4 and a y value of 3. When you look at the new A, it has an x value of 4 and a y value of 3. Let's have a look at C. You don't have to, well, let's look at B. You don't have to do all of them, but I'm just showing you one or two. So B's coordinates are -2 for x and 2 for y. And then the new B is 2 for x and 2 for y. So can you see that the y values are not changing? Can you see that? So nothing's happening with the y. The y is staying as it is. So what is happening to this y? Nothing. So just leave it as a y. But if you look at the x values, it goes from -4 to +4. From -2 to +2. So the x value is changing its sign. So here we have a positive x. So here we'll have a negative x. Don't say, yeah, but Kevin, here it's negative. All I'm saying is that whatever the x was over here, when you put it on this side, it's the opposite. So if this was an x, this is a negative x. And that is your rule. Triangle ABC is inscribed in the circle below. Okay, they haven't done that very nicely, but just pretend that it touches over there. AC is 5. AC is 5. Okay. BC is 4. And then AC is the diameter. Okay, so AC is the diameter. They really didn't do that nicely. The first question says, calculate the length of AB. Well, that's very easy. That's Pythagoras. Because if you have 5 and 4, then how do you find this one? Well, Pythagoras. So remember, you will say that, we know that with Pythagoras, if you add the two smaller sides, how do we know which one's the smaller sides and which one's the longer side? Well, the hypotenuse, the longest side, is the one that's opposite the 90. So this is the longest one. So if you add these two, then it will equal this one. But obviously, you have to add them with the power of 2. That's Pythagoras. So you can just say here, Pyth. Okay? That's the formula of Pythagoras. It's this one plus this one equals this one. Okay, now we're just going to go fill everything in. So we don't know what AB is. What is BC? Well, BC is 4. Whoops, that's a plus. BC is 4 and AC is 5. Okay, so then we're going to go AB squared plus, now what is 4 to the power of 2? Well, that is 16. What is 5 to the power of 2? That's 25. Then take the 16 to the other side, where it becomes negative. Then you're going to get a 9. And then you take the square root. What is the square root of 9? It's 3. So this one will be 3. If you got an answer of like square root 41, that's because you plussed when you were supposed to, minus. Okay. Now the next question says, calculate the area of triangle ABC and the area of the circle. Calculate the area of the triangle and the circle. Okay, so let's do the triangle first. Now, we know that a triangle is half of the base multiplied by the height. The base and the height are the two that make the 90 degrees. So, this could be your base, for example, and this could be your height. It doesn't really matter. You could also say, this is your base, and this is your height. You get the same answer. Okay. So that's just going to be triangle ABC's area will be a half times the base, which is 4, and then the height is 3. And if you had to work that out, you get 6 centimeters to the power of 2. Area is always measured in 2, or to the power of 2. Then it says the area of the circle. Now we know, what is the area of a circle? It's pi radius squared. If you said 2 pi radius, that is circumference. That's not what we're looking at right now. Now they told us that the, or let's rather say here circle, otherwise it looks like I'm saying 0. They said use pi as 3.14. Okay, 3.14 multiplied by the radius. Now what's the radius? Is it 5? No. Remember, when you have a circle, the part going all the way across is called the diameter, and then the part going halfway, that's the radius. So if the diameter, which is AC, is 5, then the radius would be half of that, which is 2.5. So we'll say 2.5 to the power of 2. Go ahead, type that on the calculator and round off to 1 decimal because they've asked us to do that. That'll be 19.6 centimeters squared. And then this last one says, calculate the shaded area. Okay, so then obviously the shaded area, which is the part that's shaded in black, would be the circle minus the triangle. Okay, so shaded will be the circle minus the triangle, and so that'll give us 13.6 centimeters squared. Determine the volume of a cylinder. Okay, so let's stop there quickly and just think about a cylinder. Cylinder is like a Coke can. Okay, so you've got that over there. And they said the volume. Now remember, we've spoken about this before, but what is volume? Well, volume is area of base multiplied by height. But let's talk about that a little bit more. So volume, let's say for example, you want to fill this container up. Let's say it's a Coke can. Let's say you want to fill it up with Coke. So if you had to pour Coke in at the top, you would first start filling up at the bottom. Okay, so let's fill that up first. What shape do you see there? That is a circle. Okay, so a circle, and you would fill up all of that. So that entire area of that circle. So a circle area is pi radius squared. Then as you start pouring the Coke, you're just adding more circles on top of each other. More circles on top of each other. And so you would simply multiply that value by the height. And that is how you get the volume. Volume is the area of the base, which is the circle. And then you just multiply that by the height in order to complete the entire shape. That is how volume works. Volume is quite easy. So they've asked us to use pi as 3.14. Now the radius is 7. So there they didn't really say radius, but they've used r, so that's good enough. And then the height is 20. And then always make sure that these are the same, which they are in this case. Okay, and then you're going to round off to 1 decimal place like they asked us to, and that'll be measured in centimeters. Now because it's volume, we'll say cubed. The double bar graph below shows the results of a mathematics test in 3 grade 9 classes. Okay, so you've got 3 classes. You've got 9A, 9B, and 9C. And it looks like, so it looks like, so for example, in class 9A, there were 24 people who have a dark gray, which means that they passed. And then there were 14 people who have a light gray, meaning that they failed. Okay, so it says which class had the most learners who passed. So a pass is a dark gray, and the highest dark gray is 9A. So you'll just say here 9A. What is the mean? Now mean is another name of, or another word for average. Average. What is the average of the learners who failed for all 3 classes? Okay, so we got the learners in 9A who failed. There are 14 of them. In 9B, there are 21 of them. And then in 9C, There's 20 of them. Okay, now how do you work out average? Well, you know how to do that. Let's say you have English, LO, Afrikaans, natural science, maths, EMS, and technology. Let's say those are your subjects. And for English, you got 70. LO, you got 68. Afrikaans, you got 72. NS, you got 48. Maths, you got 54. EMS, you got 71. And technology, you got 60. How do you work out the average whenever you get your report? Well, you add all the numbers together, and then you divide by how many numbers there are. So you're going to add these three numbers together, and then you're going to divide that answer by how many numbers there are, which is 3. And so if you had to work that out, you get 18.33. Then this last one says, use your answer from the previous question and voice your opinion. If you think the teacher will be happy with the marks represent above, give a reason for your answer. Okay, so what this number means is that in every class, or on average, there were 18.33 learners who failed in every class. So I definitely don't think the teacher will be happy, because you can see that in this class, this class did quite well, 9A did quite well, but 9B and 9C did really bad. Like, most of the people failed. More people failed than passed. So will teacher be happy? Let's say no, teacher will not be happy as many learners failed. A coin is tossed and a dice is rolled. Okay, let's talk about that. So if we have a dice, okay, you know a dice when you're playing like a board game, you've got like a 1 dot, and you get a 3 and a 4 and a 5 and a 6 and a 2, and and then when you get a coin, okay, I don't know how to draw a coin. Okay, there's a coin, you get heads and you get tails, right? You get the two sides of a coin, the one's called a heads and the one's called a tails. Okay, now it says represent the above scenario in a tree diagram. Okay, so what you do with a tree diagram is choose. Do you want to choose a coin or a dice? Let's start with a coin. So for a coin, how many options do you have? You've got heads and tails, so you've got 2. Okay, heads and tails. Now, at the end of every single one of these, you're going to roll a dice. So with a dice, how many options do you have? You have 6. So 1, 2, 3, 4, 5, 6. And then 1, 2, 3, 4, 5, 6. If you decided to do the dice first, then you would have started with 6 options. And then on each of those, you would have rolled a dice. You would have flipped a coin, which would have given you 2 options. So you can either choose this one or this one. Okay, both of those are correct. Represent the above. Okay, let's just go here. Rolling a 1, a 2, a 3, a 4, a 5, or a 6. A 1, a 2, a 3, a 4, a 5, or a 6. So we've done that one. How many different possible outcomes are there? So to work out the possible outcomes, you just count all of these ending parts. So it's 6 plus 6, so that would be 12. Okay, think about it. You could roll a heads and a 2, a heads and a 3, a tail and a 4, a tail and a 6, a heads and a 5, a heads and a 6, a heads and a 1, a heads and a 4, a tail and a 2, a tail and a 3, a tail, a 1, a tail, a 5. So I'm just going and finding all the possible combinations, and you would see that there are 12. Okay, so it says, what is the probability? So out of all the 12 different options that you could get, what is the probability of getting a tail and a prime number? Now, prime numbers are numbers 2, 3, 5, 7, 11, but the numbers that are relevant to us are those ones. So they want it to be a tail and then a prime number. So 2, 3, and 5. Okay, So out of all 12 combinations, maybe some of you might like to think of it like this. You could roll a 1, a 2, a 3, a 4, a 5, or a 6, and then you could do a heads and a tails. So if you do this one, that would be a heads and a 1. If you do this one, a heads and a 2, a heads and a 3, a heads and a 4, a heads and a 5, and a heads and a 6, or a tail and a 1, a tail and a 2, a tail and a 3, and a tail and a 4, and a tail and a 6. This is just a different way to understand it. So see there are 12 options. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And that's what we've already said. Now, out of those 12, to be able to get a tail and a prime number together, then it's only going to be T2, a tail and a 2, a tail and a 3, and a tail and a 5, like I showed you over here. So out of 12, there's only 3. Now, if you type it in the calculator, it'll simplify to 1/4.